Right, so here's an example for class 9. I decided just to pick some out of the book. This was ones that I think they've been assigned in other years that were for homework associated with this particular class. We have 110 newtons right here acting in the vertical plane parallel to the YZ plane right here. All right, so this is the YZ plane. So they're saying that this is acting right here, and then they show that it's coming down at 15 degrees. And is applied to the 220 millimeter long wrench right here. All right, so I think that they're saying that this right here is 220 millimeters. Is what I'm understanding here. So this is like a wrench, right? So this is like a socket wrench with an extender right in there. Replace the force with an equivalent force couple system right here at O right here. So it really, this is a lot of the same things that we've already been doing. So should be pretty familiar with you. What we're going to do first is we're going to figure out the position vector. Let's get the position vector from B. So it's going to be B with respect to O right there. So that's going to be RB with respect to O right here. So we're going to travel in the X direction, but you'll notice that this thing has an angle right here. So in the X direction, it's going to be this 220 times the cosine of 35 degrees right there. And in the Y direction, it's just going to be up 150. That sounds right. And then in the Z direction, the Z direction is going to be the negative of the 220 times the sine, because it's going to be that distance right there. So let's put that negative 220 in the sine of 35 degrees. So we're going to get 0.1802 I. Well, I turned it to meters, right? So this was in millimeters. I'm going to turn the thing into meters. I do this. It's like my thing. It's my jam. 0.1262 K, and now I've turned those into meters. So I did that along the way too. And now let me put what this force is going to be. Did I already break it down? I guess I did it. Let me make sure that it's clear. All right, so that this force that's acting on right there. First off, it's 0 in the I direction. It's going to be in the negative Y direction, so it's going to be a minus 110, but it's going to be the sine of 15 degrees, J. And then in the Z direction, Z, it's in the positive Z direction, so 110, and now it's in the cosine of 15 K, and these are newtons, so it's going to turn out to be 0I plus minus 284.7 J plus 106.3 K, and I like to put a little space in there so you don't think they're kilonewtons, right? So okay, so this also would be equal to R when we come down later. So the equivalent force system, it's a pretty simple straight one. So when we get the moment, we just take R, B with respect to O, and cross it with that force, right? So you should be pretty good at this by now. You must have done it a bunch of times, hopefully. We get a lot of practice. You're like a cross product whiz right now, right? You're going to be the best at it. I started to put decimal places in there. Blunt. Negative 284.7 and a 106.3. right? So let's do this. We start out with I, cross that and that right there, right? 0.1150, 106.3 minus 0.262. That's supposed to be a 6. And negative 284.7. And that's I. Now we're going to go, and I always forget this one, got to go minus, right? So I'm going to stick them right here. Minus on this second one. And go that to cross to that, and that cross to that. So 0.1802 times our 106.3 minus our negative 0.1262 against 0. That's nice, right? And then lastly, we are going to go the determinant of that right here, crossing those against each other. 1802 negative 284.7 minus, but that's going to go to 0, so it's not going to matter. That's all right. We'll put it down anyway. Then we got K, and these are going to be Newton meters, right? Because we turned everything into meters up above here, so we're at newtons and meters. So we got our M happening at O. I probably should have stuck that O in there, somewhere in there. Ends up with 112.35 I plus a negative 19.6 J plus a negative 5.130 K, and these are Newton meters, right? So, and then we could also say with the resultant that's happening onto the thing, we had that up above, as I mentioned before. That's just this right here. So we can repeat all of that down here. So it's a negative 284.7 J and a 106.3 K. And these are newtons. That's supposed to be a K. There you go. So here's our two answers as part of that. And if we wanted to, for the moment onto the thing, if you want to take a look at what that looks like, I went ahead and drew the thing out right here. What you're seeing is you got 12.35. We could draw it this way right here. Let's say that's 12.35. We're going to go negative 19. So this is slightly longer than that. And this is negative right here, right? So remember, this is all right-hand rule stuff, right? So, you can draw all of these things down here, and maybe even draw it like that right there. And now, if we draw a line right there, right, that could represent our vector. And right-hand rule, we could say that the thing is spinning like that right there. You could also say, based on the right-hand rule, that we are spinning this way about here. We're spinning that way about here, and we are spinning this way about that axis. That's what each of these means right here, and looking at the sign. So it's good to, I think, to keep that in mind, what that represents in terms of it, the motion that it's attempting to make, because this is statics, not dynamics yet. So there we go.